Hi everyone, welcome to GuiNet again. So let's continue our session about the Versa SD-WAN. So till now, let me just share the screen and then we can continue. So till now, we just try to understand about the lab topology, how it is going to be configured. We try to understand about the head-end component, what does mean the Versa director, Versa analytics, Versa controller, what is the different component of the Versa analytics, and we also understand how the Versa controller can be deployed with the help of the VOS, that is a Versa operating system, and what are the different feature we having the VOS, right? So how they are supporting the networking, firewall, next generation services, SD-WAN feature and everything, right? So I hope you guys having the basic understanding about the Versa now, about the northbound and southbound, we are understanding how this branch offices can be connected on a different internet and the MPLS and everything. Now I'm just going to focus a little bit more about the SDN solution. Okay, so still I didn't discuss about the why SD-WAN. Okay, so let me just discuss about why SD-WAN. So basically, when we talk about the SD-WAN solution, we just have to understand what is our WAN legacy solution, legacy WAN solution. So we talk about the legacy WAN solution. This is known as the wide area network. So we call as a wide area network. So in this wide area network, what is the problem? Why we move to SD-WAN solution? So let's discuss one by one. Okay. So if I talk about the problems, so there is a lot of problem which is going to mitigate by the SD-WAN solution. So what are those problems? So I'm giving one of the example. Let's suppose we're having the branch locations in the different locations. Like these are the all branch sites which is hosted in the different locations. So you having how many branch? 1, 2, 3, 4, 5, 6, 7, 8, right? They all are connected with ISP. Could be the internet, could be the MPLS. This is how they are connected, all the branches. Let's suppose one day your team lead, your managers come, your might be the customer comes, and they are going to ask you, hey, you need to just upgrade the iOS. Then what you're going to do? Simple requirement, just you have to upgrade the iOS. So probably you have to log into all the devices and step by step, you just have to upload the iOS if you already downloaded somewhere and it is reachable from your router. TFTP server reachability is there, then you can easily upload the iOS and then you have to take a downtime from the customer and then you can upgrade the iOS one by one for the all location. It is not possible. You can schedule everything in one go and at the same time, and it can be achieved in the one place. No, it is not possible. But this is very simplest things. If everything is in place, then it is possible. Okay, but it is not too easy to do a router upgradation in the production environment for your legacy systems. What happened might be your LAN doesn't having that iOS available. TFTP server is not available. So a lot of challenges might we have to face. So what next? So in that case, probably you just have to arrange the field engineer for your site. So if he is going to be arranged for your sites, okay, and his laptop should having the TFTP server software installed, and on that TFTP file, they have to download the iOS from the concerned vendors, might be the Cisco, Juniper, or Versa, whatever you think. And then this is going to be connected to your switch or router, whatever we have. And through that, LAN cable, you can just upload or download the iOS from the PC to the router. And then it is going to be changed the boot sequence, boot variable, and then it's going to be upgrade the process or downgrade the process. So it is going to take a huge time. Might be the 4 hour, might be the 8 hour, even sometime more if the correctly internet is not working, some other issues arrive, unknown issue if you don't know. So this is how it is going to work. So it's quite complex, quite lengthy. So if you're having 1,000 router, probably it is going to take more resource, because one resource cannot do the 1,000 router IoT upgradation in one go. So you might be required more time, more resource, more cost. If you're having the resource, time, cost, everything is going to be occur. But if it's the same thing, if you have to do the SD-WAN solution, it is quite easy. Okay. So you just have to schedule the things from the controllers, right? So controller, that means your management system, that might be your Versa directors. And from there, you having 1,000 router, you can just deploy all the iOS in one go from the one location. And it is absolutely possible in the SDN solution. So this is one definition. Similarly, if you want to do some kind of the like, let's suppose this is one router and this is another router, and you just have taken the two links for the different ISP, and you having the LAN connected here, right? So how the legacy system works? So this is the behind the LAN, we having the user connected somewhere. So might be this link is acting as active and this is acting as a primary. Okay. So in legacy systems, basically, if the primary link goes down, then only the traffic basically shift on the secondary link in the real time scenario. Somewhere we can set up the some kind of the manipulation, we can do some kind of the route based manipulation, we can send some of the traffic for this particular link, some of the traffic this particular link, but it is going to add the complexity in the network in the troubleshooting point of view. So generally in production environment, people will do basically make one link as active, another as a passive. So at a one time, the all traffic keep going with the active link, another link keep sitting in the idle. And if the one link goes down, then the traffic will pass to the secondary link. This is how the traffic is going to be processed. So this is the one design. But you don't think like if this is useless, not coming in a picture unless it is goes down, then we are wasting our resource, we are wasting our bandwidth, we are wasting our cost. So it is not a good choice. But if we are going to use the same SD-WAN solution, probably you can use the both of the link at the same time, and it is not based on the destination, even the based on the applications. So let's say suppose you want to do the routing, like if your data center routing based on the destination for this link, you can do that. And you want to do the application based routing, like you want to send the YouTube based traffic, Google based traffic, right? You want to send the Facebook based traffic, WhatsApp based traffic via this link. It is also possible in the SD-WAN solution. So application aware routing. So SD-WAN fabric basically understand the application behavior, and based on the application, it is going to treat the traffic based on the whatever you have configuration you have defined in the SD-WAN fabric. So this is another benefits we have in the SD-WAN. Now another things you just think about that these two links are keep working fine for you, and let's say suppose everything is going great, okay, but failover is going to happen only the scenario when this link is going to be down. This link is going to be down. Then the failover is going to happen. Let's say suppose this link is not going to be down. The link performance going to be degraded. Link performance might be the link having a latency, loss, packet loss, right? Some other jitter. So if there is a link latency loss and packet loss, loss latency and jitter in the circuit, then link is not down, right? This link is not down. Then how the failover is going to happen? This failover is not going to happen. So if there is a no failover, then how the traffic is going to be moved to the R2? It is not possible, right? Because it is only move when we having the link is going to be down. Because you might be configure the SLA tracker for the, if you're running the VRRP, HSRP, you are doing the WAN tracking and all, running the BGP, they only come in a picture when your link is fully down or they are not meeting the SLA criteria. But if the performance of the link is down, there is an issue in the cloud itself. For any region in the internet cloud itself having the issue, is still your traffic, business traffic is start suffering for you. So it is not going to process via the secondary link. So in that case, might be you will be the clueless. So your user is sitting here, hey, keep complaining, hey, I have the bad quality to accessing the application, right? So might be the NOC team will again reach out to you. The customer support team will reach out to NOC team, and NOC team will again reach out to L2 or L3 engineer. Hey, this site having the bad quality application issue. The user is facing the slowness. The user is having the issue while accessing the different services. So you can start the troubleshooting. And if you start the troubleshooting manually, you come to know, hey, this link having a problem. So you come to know this link having the problem. You find there is a loss latency and jitter. So probably you can try to think, do the manual failover. So you can try to do manual failover from primary link to the secondary link. So if you try to do the manual failover from primary to secondary link, so you just have to do a lot of configuration. Might be here you are running the BGP, here you are running the OSPF, you are running the HSRP as well. Anything you are running, so you just have to think 360 point of view for the everything, how the traffic can be manipulated. If you don't think about that, then the traffic is not going to be manipulated for you. And it could be if you miss anything wrongly, you configure anything wrongly, then it is going to lead to another escalation for you. Might be your network failover is not having correct way. and complete outage is going to be happen. So there is also possibility. But let's say suppose you are the very good engineer, you having the complete understanding about document design and everything, and you can define the correctly all over the failover process. In that case, failover is going to be happen, right? So your failover from primary to secondary is going to be shifted, right? So this traffic start going from this way to this way, and it is keep going to the internet. But again, the linkage came up, then you just have to do the again failover from the this one to this one, because you just do the manual failover, not auto failover. So it is not going to automatically shift the traffic. So this is how the problem was in the legacy WAN technology. But just think about the same scenario. We having the two router, R1 and R2, right? Again, having the two ISP. And below that, I have a LAN. And this is how it is connected. And this is the PC where the LAN is connected. So in this PC, if I am using the SD-WAN solution, so in legacy WAN, if this link was down, then the failover was auto happening on this link. But performance was down of this link, loss, latency, jitter was on this link, this failover was not happening. But if I am using the SD-WAN solution, this router is very intelligent. They know how to treat and how to read the traffic, how to read the statistics. If there is a loss, latency, and jitter itself, then it is going to be transferred to the secondary router automatically. It is going to transfer to the secondary router automatically, because they will just monitor something based on the SLA, and it is going to be transferred. Okay, just give me 1 second, guys. Okay, so this is going to be done automatically. So this is the again, like, no your manual intervention is going to require, no your any engineer support is going to require, no any knock need to be engaged, no customer need to worry about the services. The quality of this link is degraded. Customer never going to realize what is my quality of the services. They will automatically understand, and they will automatically fail over to the secondary link. Okay, so this is how it is going to be happen in the SD-WAN solution. So this is about the SD-WAN solution. So we're having a lot of features. Let me just show you how it is going to be happen in the real environment. So you can see here, complex operation, high cost, limited scale in the legacy WAN. So this is the all challenges we're having in the legacy WAN solution. Disjoint solution. Disjoint solution, that means, let's say suppose you want to run the security, you want to run the riverbed, you want to run the some kind of load balancing. Just you have to build, integrate a lot of solution together to achieve that all requirement. But if you are going to use the SD-WAN solution, it is absolutely possible, absolutely useful. You can use the same solution and you can deploy it for the using of the one of the vendor solution of the SD-WAN, and you can get all the overcome by using the SD-WAN solution. Okay, bandwidth issues, limited application awareness, fragmented security, no cloud app readiness, everything. So these all things is going to be covered very easily. No need to worry about that in the SD-WAN solution. So it is possible either the Versa SD-WAN if you are going to use, Cisco SD-WAN you are going to use. This is the lab topology what we have, like we are just going to cover in our session, and that is absolutely possible in the Cisco SD-WAN also. Okay, guys. So moving one step ahead, right? So let's say assume that if you want to build the any of the SD-WAN fabric network topology, so how basically it is going to be formed and how it is going to be built. So basically, this is like one of the topology. You can see we having a different branch, and all branches need to talk to each other. So how basically going to talk? So basically they are going to connect with the ISP, and over the ISP, they will do the communication. But how it is going to happen, this communication? Over the internet, over the MPLS, over the other some routing protocols? The answer is yes, it could be possible. But if you talk about the SD-WAN solution, with the underlay IPsec connectivity, whatever we have, that is just going to give you the underlay connectivity, just basic IP reachability. On top of that, you can just build the overlay IPsec connectivity or overlay routing protocols that we are going to cover in the different section. What is the meaning of the underlay and the overlay? Okay, so that is one thing. So in our lab, basically you can see this one. If you go here, these are the, let me just go and try to log in it again. So if I go here, you can see this is our lab. We having a different branch locations, branch side, data center, and controller locations, which we already have discussion. So I was keep talking about these things, how SD-WAN is going to mitigate the problem of the different kind of solutions. So if I compare that problem, so you just understand in this way. So see, this is the legacy branch office WAN architecture. Okay, so this is the legacy one. Okay, in this legacy one WAN architecture, what we have in this legacy WAN architecture, you can see, let's say suppose user want to go on the internet, it can go via this path. If they want to go in the MPLS, they will go via this path. So what we have, might be user is connected with the Wi-Fi user. This is a user sitting here. And this Wi-Fi user is further connected to the switch. This switch is further connected to the WAN optimization. This could be the riverbed or some other WAN optimization. Then it is again connected to the SD-WAN router, or might be the normal router, whatever we have. And then you can see this is connected, and then it is connected to the firewall, and then it is going to the internet. If it is going to the MPLS, you can see this is again user here. It is connected to the VP, that is a switch, that is the WAN optimization, that is the SD-WAN, that is the WAN router. And MPLS, basically the firewall is not required because this is the secure connection, the private connection. So directly they will go to the MPLS network. So it will directly go to the MPLS network. So see how much devices we have. We just have to take the access point. We have to take the switches. We have to take the on optimizations. We have to take the SD-WAN. We have to take the normal routers for the WAN connectivity, and then security firewalls, and then it is going to the final build. So you can see how much skilled resource to require to manage these devices, how much cost required to purchase these devices, inventory and everything. So if I just replace this with the Versa SD-WAN solution, it all box can be replaced with a single box. And this having the same feature, what they all are doing here. So what they are doing here, it can be done by the Versa SD-WAN single router here. So everything, so whatever you just think can be covered by this Versa SD-WAN router. So what basically they do that, you can see in the security stacks, you can see your firewall can do the packet, gate packet, bridge packet, route lookup, QoS, DPI inspections, right? And they can do the, your WAN automation, do that, the gate packet, bridge packet, QoS and DPI encryption, TCP. So these all features, router can also do the same kind of the stuff. SD-WAN can do the same kind of the stuff. So they all are doing the similar, different kind of the stuff in a different layer, right? But if you talk about the SD-WAN, it is just going to replace all the feature in the single router, which is capable to do all the things what they are doing in the different places, like git packet, bridge packet, route lookup and QoS, DPI, everything, all feature are already included here. You can see that. So in the legacy environment, whatever things is done by the different router, different firewalls, different switches, that is absolutely replaced by the SD-WAN features that having the almost same feature, or I can say more than them feature. Okay. So why we go and buy the multiple devices? Hope it makes sense for you guys, right? So you can see here, they are talking about the legacy SD-WAN implementation are low performing, complex, slow, and the unreliables. Multiple WAN devices to manage, multiple management devices, system to learn, need to many resources and skills to just manage the devices, slow to change, right? So you just have to, not too fast change because you have to take a lot of approvals, lot of justification required, like consumer space and power, because they all devices require the space, power, cooling capacity, security compliance issue, poor performance for the SaaS, poor visibility because they're having their own architecture, all platform that is not, single pan system kind of system where everything could be monitored by the sitting on the one devices, right? So this is how basically legacy system was, right? And different hardware having a different processing, different system. But if you talk about the secure SD-WAN solution, so you can see this is the secure SD-WAN architecture, the zero touch single software stack running in the single device. So everything, like whatever the feature I talk about, right? So if you're running the VOS, like the Versa operating system, this is the single software network and security stack, which is inbuilt in the within the box, and they perform the only one WAN device to manage, just one WAN device to manage, only one management to the system to learn, minimum resource skill required. Because in earlier cases, you're just having the multiple vendor devices, Riverbed, firewalls, checkpoint, whatever you just think. All the skill resource could be required, fast to change, right? Resilience to failure, dual box, HA solution is possible here, minimum space and power because you just have to manage one box, minimum coolings, enterprise-wide security compliance, optimized performance for the SaaS, full visibility. So everything, whatever you can think, everything available in the zero touch provisioning to other features in the your SysD SD-WAN solution. So hope it makes sense, guys. And you can see it also perform the same gate packet, trace packet, route lookup, DPI, QoS, next generation firewall, security policy informants, load balancing, SD-WAN, traffic steering, conditional forwarding, TCP optimization. They provide the similar kind of the stuff in the network, right? So this is our old architecture. That is a legacy WAN, which having the very complex situation where might be the multi-box solution cost to the $1,000, which is going to replace with the zero touch one box, which is just going to cost you $1,000, right? $100,000 and it is $1,000. So how it's 100 times you are going to save a cost by using from this to this solution. Hope it is going to make sense to you all. Okay. So next, you can see they are talking about the security features, whatever the router, security, WAN optimizer, they are just going to capture in one box for the faster processing, easier troubleshooting, better visibility, single pane of the glass. That is our, Versa director, which is going to help in terms of these all kind of the features, right? So if you talk about the secure WAN architecture, operate seamless in branch, data center, and campus and cloud and the 5G, whatever you having the connectivity and what type of the environment you have, you can just deploy it anywhere, and they provide the routing, SD-WAN solution, security. It can be, integrate with a third-party VNF, and also it can be deployed in the on-premises and cloud, private and public, whatever you can think. So this is also possible, right? And here you can see this is the different cloud providers where this can be deployed. SD-WAN OS can be deployed, like Equinix, AWS, Azure, Google Cloud, Alibaba, and Tencent Cloud, OpenStack, VMware, KVM, Microsoft Hypervisor, and GenX, right? We having a lot of things where we can securely, cloud natively, we can deploy this solution for the anywhere, right? So basically, I can say it's having the very huge features available within the single box. So again, there is a challenge how this can be basically operate and effectively give the performance about that, all the type of the processing which is going to land, because they have to process the routing, they have to process the switching, they have to process the firewall things, load balancer things, how it is going to be happen in the realistic network. So it is used the single pass software with a parallel processing concept. This is similar to the Palo Alto firewall, where we just have to get the information packet, one of the polar CPU, and that CPU is going to send the packet with the different worker CPUs. So in the architectures, what that means, let's say suppose the LAN is sending the continuous packet to the SD-WAN router, right? So once the LAN is sending the continuous packet to the SD-WAN router, so this router is just one device, right? And it is receiving a huge packet from the LAN segment, and they have to process different kind of the data. It could be the security packets, this could be the firewall packet, load balancer packet, some other routing packet, some switching packet. So how basically it is going to be handled? So it's used the parallel processing similar to the Palo Alto firewall. If you know the SP3 architecture in the Palo Alto firewall, you can just correlate. So SP3 architecture was single pass with the parallel processing system. So in this case, basically, whatever the traffic is coming from LAN, the polar CPU is responsible to distribute the packet information to the worker CPU, and the different worker CPU having a different roles. Someone handling the UDP, TCP, some security, some routing, and they parallelly process like one packet to him, another packet to him, another packet to him, another packet to him. And based on the flow, they send to keep flow to different CPU, and they all process at the same time, and they just give the one time output. So it is going to become a faster. So this is how it is going to use the single pass with the parallel processing concept to just manipulate different kind of the processings for the different type of packet. So I hope it is interesting for you all, and you understand at least idea and at least about the SD-WAN architecture. And these are the Versa routers. You can see different router we have, like OB4, like we having the GS700 series appliance. You can see this is the Versa CGS 1000 series of appliance. So these can be used for the low end location, high end location. If you want to, it can be used. And this is again further high end. We having the Versa CSG 1300 and the 1500, and this is 1000. So if you want to use a data center, it's a big location, it can be used for the different location. And this can be, you can see different model of the router. Like if you are using the 1300 and 1500 of a SG router, they having the throughput capacity. One is the 10 Mbps, one is 20 Mbps stateful, SD-WAN DIA, site to site, next generation firewall, IPS, antivirus, UTM. So every speed is mentioned here. So if you're using a lower, you're having the lower throughput. If you're using the higher end router, the higher throughputs. Okay, guys. So I hope you guys understand about the theoretical concept about this Versa SD-WAN. So going forward, what we'll do, we'll try to do more practical things, how the lab is going to be configured. In the upcoming session, I'll try to onboard the first controller, and then we'll go a step by step the branch side onboarding. Okay, thank you so much.